Okay, Crewton Ramone's houseofmath.com. You guys don't. Anyway, alright. So, advanced problem solving, quote unquote. It's not really advanced. We don't have any negatives. Basically, we're playing advanced what's under the cup. But actually, we changed the game now. We've changed the game to same on both sides. What does this symbol right here mean?
Equal.
And what's another word for equals?
Same thing.
Same thing. So we're going to find stuff that's same on both sides and see if we can read it. Stop it. You.
Too easy.
Pay attention. It is too easy. So wait, hold on a second. Before we get going. Tell me everything that's here, if it's so easy.
3x.
Plus how many?
Plus 3.
Okay, so there's what it says. 3x plus 3.
2x plus 3.
2x plus how many?
2x plus 6.
2x plus 6. Okay, so can you find, do you see some stuff over here and some stuff over there that's same?
Okay.
Give me the stuff that's same. Alright. Great. So let him do it then. Good. Very good. Okay, what else do you see that's same? Okay. Let him do it! Oh, you. Alright, never mind. Okay, fine. Gotta give your brother a chance. He gets to play too. Okay, so now it says what?
3x.
What does it say?
X equals 3. X equals 3.
Alright.
It said.
Get these mountains out of the way. Alright. So now, x equals 3. So what does that mean? That means that each one, remember you were saying before that the x's can be ninjas?
Yeah.
And that they can change we never know what they are? Well, now we figured out by using algebra, but actually just by playing what's same, you found that if we took 3 from that side, and we took 3 from that side, and then we took 2x from that side, and we took 2x from that side, it's like hero 0! Hero 0! There they are, right?
Hero 0.
So if I take 6 and I take 3 away from that, how many's left? 3, right? And if I take 2x away from 3x, how many's left? 1x. So it says x equals 3, right? Okay, so if x equals 3, almost 100% better, but not quite. If x equals 3, that means that we have to replace all of those with 3. So get 3's and put them in here. Here. 2 3's there, right?
Yeah.
And get some 3's for these.
There's an equal sign right here.
Let's grab, yes. Oh, it could be an equal sign, but if we put them like this, sometimes I use these as equal sign. But actually, those are still just 2 3's, okay?
Yeah.
All right. We'll get these guys out of the way. And now, let's count. How many over here?
Oh, man.
Count.
How many over here? 3, 6, 9.
Okay, 3, 6, 9. And then those guys?
12.
12. Okay, so 3, 6, 9, 12. Okay, count over here. How many?
15.
Yeah.
3.
Start over.
9,
We have
12,
equals,
15.
right?
3, 6, 9, 12.
Okay, so stop. 12 equals how many over here? Count them.
3. 6.
Keep counting.
9, 12.
There we go. Does 12 equal 12?
Yep.
Does 12 equal 12?
Yeah. No, yeah, 12. Yeah.
Does 12 equal 12 or not?
Yeah. Yeah.
Okay, in fact, we could line these guys up, and we could say...
3. And then my brother
we're going to make them equal. Isn't that what they're not saying? Isn't that what these say?
Yeah.
Is it they have to be equal?
Yeah.
And are both of them 12?
3. We're counting for the ones who don't know.
Just one line. Just count one line.
5 3s. 3, 6. Oh man.
Just count.
9. Oh man. 12, 15.
Are you getting 15?
No. 3, 6.
Oh, if we count all of them, we're just counting one row.
3, 6, 9. 12.
Okay. And then 3, 6, 9, 12.
But if we add them
so over here I have 6. 6 plus how many?
6 plus how many?
I went up with 6 plus how many green ones?
6.
And over here I went up with 9 plus how many green ones?
3.
So, are they same?
Uh-huh.
Even though it's 3 plus, or even though it's 9 plus 3 and 6 plus, 6 plus 6, still the same, right?
Yeah.
Okay, can we make another one?
I think I'll go for 1 or 2.
Alright.
I think we should do another one.
Alright, let's do another one.
3.
Okay. Get it set up. I have 5x plus 2 equals 4x plus 7. So get the pieces out that you need. Let's get these guys out of here. Alright.
Is this the x squared?
How many x do I need over here?
Over right here?
What's it say? So it's 5x.
5x.
Now you, how many on your side? How many do you need over here?
4.
So get 4.
1, 2, 3, 4.
Alright. Count it out 4. Okay, I got 5. Are we done? We've got to set up this one now. How many units do you need? Yeah, they're all over here.
Wow, my units.
Okay.
My units too?
Alright, so you need to get some units. Oh, you can get some units underneath here too.
Yeah, you forgot my units.
Alright. See, and this is why we need more time. And like I said, when you have the little boys, they don't film so well because they're fooling around and playing. But now we have lots of time, so it doesn't matter. Alright, so how many do we have there? We have 5x and 2. And over here, your side needs to get set up, little boy. You need 4x plus 7. How many do you have there?
4.
Well, it says 7, so does he need some more?
He needs 3 more.
Very good. So get 3 more, please. Okay, I'm going to put these guys back over here. Alright, so now we've got it set up. And see all the math that goes on just in setting up the problem? 5x plus 2 equals 4x plus 7. Now you guys got to have your stuff the same. Okay, so take out, do you see stuff the same on both sides again?
Yeah.
Alright, so give me stuff the same. Oh, immediately, put it here. Alright, so he took out, the first thing he took out was 4x. So what are you going to do? Give me what? Is it same as this?
1, 2, 3, 4.
Okay. Now, how many units over there?
1, 2, 3, 4, 5, 6.
Okay, wait. I'm saying that he took out. Now he just took out 2 while you weren't looking and you were counting. So he took out 2. How many do you have to? How many do you have to take out? How many do you have to take out to be the same? Very good. Okay, so now see, look, we have same stuff down here. Now, what does it say? What does it say?
X equals 2, 5.
Very good.
X equals 5.
All right. So now that means that we're going to put in 5s for how many we had before, right? So grab some 5s. How many 5s do we have to put in on both sides?
How many 5s?
All right, let me do some math over here for the people watching at home. Grab some 5s and put them in. Okay, so over here, first thing he did was he took out 4x, and over here he took out 4x. 0, 0! And he was reluctant to give up all his x's. And then he took out 2, and then he took out 2 from over here. Whoop, okay, so got another 0, 0, and I left
3 5s.
Why do you have 3 5s if you're supposed to have all of those are 5s? All the x's are 5s.
1, 2, 3, 4.
So now I see that x is the same thing as 5. That's right, he needs 5 5s.
55.
Alright, how many 5s do you need?
4.
Okay, it gets 4 5s. We're waiting. Oh, he has to reach those. Okay, and put them in for yours. Now we got to do some counting.
Squid.
Okay. Count them. Counting by 5 is super easy.
5, 10, 15, 20,
See, and that's the idea, is we make it super easy for the, right? They put them in a position where they can't feel.
25 units.
Okay, but what about those 2?
25.
And 2 more.
But all my units. 27.
Very good. Right, so 5, 10, 15, 20, 25, and 2 more is 27. And over here, look at him, he's lining it up so they're easy to count. Very good. Alright, so now we can leave these 2. So again, what do I have? You count.
5, 10, 15, 20, 25.
And what about those two more?
5, 10, 15, 20, 25, 40.
25, and then what?
5, 10,
What comes after 25?
40?
What comes after, well, if I'm counting by fives, but I'm just saying, 25, and another one is how many?
5, 10, 15, 20, 25, 40.
Is that a 5?
No.
Well then, how many is it?
1.
So count by ones afterwards. 5, 10, 15, 20, 25, 26, 20...
8.
How did you get, what happened to 20? Alright, let's count again. 25, 26, what comes next?
26, 27.
27, there you go. How many over here?
Oh. 5, 10, 15, 20, 25. And 2 more.
And 2 more.
The same as mine.
Exactly. The same as yours.
But let's count.
Oh, well, we've counted enough. We know that 27 equals 27, right?
What's 27 plus 27 now?
Ooh, there's a good question.
Yeah.
That's completely different. But if I said 27 plus 27, how many would that be? Let's count them. Let's just do that for fun. Has nothing to do with this problem.
Yeah.
But, well, sort of it does, but we can count and see what we have. Okay, count them.
Okay.
Let's put them all together.
All
these guys.
10, 15, 20, 25, 30, 35, 40, 45, 50.
Mm-hmm.
Plus 4 more.
Mm-hmm. What's 50 plus 4 more?
54.
There you go. Pretty simple, right?
Look, it equals 54.
Yep, that's a lot, isn't it? Right? The numbers get bigger and bigger.
Units. I can get my 10.
Okay, so let's make another problem and see what happens. You guys got to make the problem again, right?
Yeah.
And we'll discover what x is. Okay, so here's the new problem. 4x plus 1 equals 2x plus 9.
Yeah.
Just get out the blocks that you need. He's got his 4x. Now how many units do you need? How many units do you need? How many does he have?
2.
Okay, so get rid of the ones that you don't need.
We need only 1 unit.
Well, then get rid of all the other ones. Alright, give them to him because he needs 9. Let's see if we can count out 9 over there. Alright, oh, and we need an equal sign again.
Okay.
Where's my equal sign? You didn't make an equal sign, it disappeared.
4, 5, 6, 7, 8, 9, 10. Yeah, it's because I have 10 of them.
Well, then you have too many. You really have 10 there?
You accidentally erased your equal sign.
Yeah. Well, we erased it last time when we were counting the two of them together. Okay, now how many x do you need? Do you have your x out?
Yeah, x did.
What do you have? I don't see any x over there.
Oh, man. I need 9x.
How many x's do you need?
No, he needs 2x.
2x, alright. And I gotta change my battery. Alright, so we've got it. And it's time for a battery swap out. Okay, now. What are we doing again?
Math.
Yeah, we're doing math. We're just doing problem solving. Yeah. We're finding stuff the same. Now here, I haven't told any stories. We should tell some stories. So, we could tell a simple moment in time story where we've got one guy that's 1 mile out of town, that'd be you, and another guy that's 9 miles out of town, that'd be him. He's going 2 miles an hour, and you're going 4 miles an hour. How long does it take you to catch him? Right? So we can okay, don't spread your units around. That's a good plan. Put all your units together over here. Alright, and you got that? Okay, so take out the stuff that's same from both sides. Quick.
2.
Alright, good. Alright, so I get 2 here and 2 here. Okay, and what else? That's same.
2 units.
What else is same?
2.
Yeah?
1 unit.
Okay.
And 1 unit.
Okay. So now we see. Uh-oh.
What?
Did I do that?
What?
How did you have 2? Oh, you had too many to start out with. You didn't count correctly. Let's start again. The older boy. How many do you have over here?
4, 5.
What's it say?
4.
Mm-hmm.
Distracted.
Alright, so you got to be able to set them up correctly to start off with. Alright, so, now let's do it again. I could look at that and see that there was a problem. If I took away 2 from this side and 2 from this side and you still had 3 over there, there was a problem, wasn't there?
Yeah.
Okay, let's try again.
Give me some munchies.
Alright, so, give me the stuff the same. Here, right, 2. Okay. Alright. Okay, now what? More stuff the same. What else you see the same as over here and same over here? Yep. Okay, so, right, so, don't. Alright. Okay. Now, what does it say?
2x equals
how many is over there? That's what I want to know.
2x equals 8.
Okay, so I took away 2 from over here, and that left me. Oops, let me write this down. So here I have 0, and again I had 0, right? Here was 0. So I wind up with 2x equals. We're not done yet. I said 2x equals 8. So what does 1x equal? I want to know about 1x, not 2x. So if I have 2x is the same thing as 8.
1x.
What does 1x have to be? Set it up so that I have, again, this is the important part. This side is 2, so arrange them so that one side's 2 and then put them all the way out. Yeah, so basically you're going to make them by 2's. There you go. So there's 2. Give me 2 more.
2.
Okay, put it there. Good.
They were just chomping down on the road.
Okay. And see, that's why it takes way too long when you use single units. But when you start off, you have to with little kids. But can you see if it's older kids, how this would be tedious? They already knew.
So easy.
Alright, there you go. Put it right there. Okay, so now we have them set up nicely. Oops. See, and even that. Uh-oh. Oh, no. Alright, there. And there. Okay. So can you see that over here I have 2? Right? And over here I have 2? Okay, so over here I'm saying the whole thing is 8 and one side's 2. What's the other side?
4.
Alright, so what does each x have to be?
4.
Each x has to be 4.
So
you're right.
It's 8.
So it is 8. So let's put them in there and find out. And let's not take all these guys and get Chris, put everything back. So I'm going to do this. And grab me 4s. How many 4s should you have? You started off, right? Each one of your x's was 4.
Can I have 8?
You just need... Yes, you have 8, but it's 2 4s. Good. And then you should have how many 4s should you have to start off with? Since you were started off with 4x and we figured out that each x was a 4. How many should you have? Very good. Very good.
Ouch.
Alright. Now, let's count. Oops, I need the 1. Oh. Okay, count.
4, 8, 12, 16. 1.
16 and 1 more. What is that?
1, 6, 17, 4, 8, 12, 16, 20.
If this was a 4, it would be 20, but it's not. It's a 1. So how much do I have? You're right. I'm trying to get him to say it. Can you count yours? Count yours.
4, 8, 12, 16, 17.
Right. It's the next one, right?
20.
Okay, 20 is if I added another 4. So here I have, count yours.
4, 8, 12, 16.
And 1 more. Is that a 20?
17.
Is that 4 more or is that 1 more?
1 more.
What comes after 16?
17.
There you go. Okay. So do we see that 17 equals 17? In our story, it took you 4 hours to catch him, and then you would be 17 miles out of town. Right? So actually, it'd probably be better if we use minutes.
17 plus 17?
You're going to count 17 plus 17 again and see how much it is?
Okay.
Okay, let's do it. Alright, so let's just move all these guys over here. Because those guys are already set up. And we'll put that over there. Alright, so just for fun.
8, 12, 16, 20. All 4 do say how many? 24, 28, 32. 46, 47, no, 32.
Wait, yeah, 32, then what?
30, yeah, 32.
Look at him doing calculations in his head. 32 and 2 more. What comes after 32?
34.
Very good.
Yeah.
The whole thing is 34. But answer my question. What comes after 32? What's the next number after 32?
33.
33.
43.
34.
44.
There you go. Right?
Okay,
so can we set up one more problem and then we'll be done with this?
Yeah.
Okay, but see how we made extra math because they want to add them together and see how many it is? Alright, but basically what we're doing is figuring out what the rules are. Alright, and the rules are making them equal and finding stuff on both sides. And already there's going to be tower building, but wait, quick, before we lose concentration here, let's build one more problem. And hey, you, make sure that you get out the right number to match the symbols, okay?
Okay.
Alright. You're doing a great job. Okay. Alright, so now we have the new problem. 6x plus 2 equals 3x plus 11. Because they're getting more confident, they want bigger ones. So, build it. Put what you need. Make sure you got the right numbers.
Okay, have I got X's?
Just count them out there.
Oh my X's. 1, 2, 3, 4, 5, 6.
Very good. How many units do you have?
1, 2.
You got 2. Now, how many units do you? How many X do you need, little boy?
3.
How many do you have? Way more than 3. Okay, good. Subtract. Get rid of some. Okay. Now, how many units do you need?
11.
Okay.
So we need a ton of units.
You need a ton of units. Well, I'll tell you what. Let's not get out ones. Let's get out some other pieces that would be faster. What do you think? Okay. What do you think would be faster to make an 11? I'll tell you what. Here. Okay, you just keep these 2, and I'll give you a big clue. Because I'm going to leave these guys. See, the reason why I'm going to leave those guys as 2 and these guys as 2. So that what can I add to 2 to make 11?
Add to 2 to make 11? 2 and some more 2s.
2 and some more 2s. Okay, wait. Count. What do I need to make 11? Get out the pieces until you make 11. What do you think? Just grab some more. And go turn off the light, please. Good, grab them. Go ahead. Grab those guys. Grab these guys.
No? What else?
Either one, any pieces. Just grab some so we can get 11. How many you're going to need to make 11? If you have there, enough. Just grab a few. You don't have to grab them all.
This is only 6.
How many is that?
This is only 9.
Okay, put them over here with these seeing if it's right. We need to count it.
Watch this.
All right, have a seat, little boy.
3, 6, 9. See, it's
okay.
9.
It's 9.
12.
Is it 12?
Oh, 3, 6, 9.
And?
11. Yes, it's 11.
It isn't? Are you sure? Okay. So I was thinking you would just get out a 9, but since he was fooling around with those, 3, 6, 9. Actually, this is going to work out perfectly when you get right down to it. Look, their subconscious minds are going along. It's 11, isn't it?
Yeah.
All right. Good. So now we're going to see, and the only reason why I left these 2 guys out like that is because we had the same over here, so it'd be really easy to see what's same. Okay, so grab me the stuff that's same from both sides. Excellent. Yeah! Alright. There's those 2. Now what?
Yeah.
Yep. Okay, just hand them to me. And. Okay. Now, hand me those that are same. Alright. Now, uh-oh. Now what does it say? So we took away 2 from both sides, so we subtracted 2, and then we subtracted 2, And then we subtracted... What are you doing? But what?
Look, we're not supposed to have... then why did you say uh-oh?
I didn't say uh-oh. Did I say uh-oh? Well, look. Oh, okay, I said uh-oh because I have 3 over here. And I have 9 over here. So I'm trying to figure out what each x is. I don't want to know about 3x, I want to know about 1x.
Each x is 3. 1x is...
How do you know each x is 3?
Because...
Are you psychic?
Over here.
Because it's 3's over there?
Yeah.
He's psychic? Okay, so he's able to see that 1x is the same thing as 1x over here? Or excuse me, 1x over here is the same thing as 1, 3 over here. There's a correspondence of 1 to 1. But can we make our rectangles and take a look at this closely and see that right here I have 1, 2, 3, and on the bottom of this one I have 1, 2, 3, right? Okay, so now let's figure out what the numbers are. Oh, and let's do some math. For those watching at home, what do we do? First we took away 2, and then we took away 2, and then we took away 3x all the way over here, and we took away 3x over here. So that's everything subtracted. I know teachers that really get upset when kids do it this way. They want to rewrite it over and over again so that they can make the math as tedious as possible. Alright, and then over here I have 3x equals 9. Right? After I get done cleaning all that up. That's a 0, that's a 0, this is a 9, and this is 3x. And the little boy was able to look at that immediately and see that each x was the same thing as 3. So let's write that last one. I'm going to write it in blue just for fun. X equals 3. See it?
Yeah, it's not black, not red, blue.
Alright. So now we got to put 3's in for everywhere there was an x. So here I'm going to have 3 3's, right? And 11, and I'm going to make my 11 faster with this and this. And then over here I should have had how many 3's? I should have 6 3's, right? And 2. Alright, so count. How much do we actually wind up with?
Okay, let's put them together.
Alright, so we know let's just count one side and find out what it is.
12, 15, 18, 3, 6, 9, 12, 15, 21.
We'll count it again. Let's count it together.
3, 6, 9, 12, 15, 18.
Okay, and then what? 18. What comes after 18?
20.
Good. Okay, you counted them both. Okay, so 18 and 2 more is 20. Now let's count over here. Look at him fooling around.
All
right.
I'm not fooling around right now.
Okay, so put them over here. Put your 3's here. And then I have this 11 over here. Can we count it? What do we have?
Yes.
Count it.
3, 6, 9.
Got 9. Plus another 9.
Is 9.
How much is 9 and 9?
9 and 9.
Mm-hmm.
Plus 9. 9 and 9.
Mm-hmm.
11.
9 and 9 is 11.
Okay.
What's 9 and 9?
Not 18.
Very good. 18.
9
right?
and 18.
Right? Because that's right, because we're counting by 9s. But you could look at it this way, because it's 3, 6, 9, and we could find 3 more 3's in there, 3, 6, 9 more to make 18. Or we could look at, what does 9 want to be?
10.
What does it need to be a 10?
1.
1. So if this 9 took 1 out of this, I would have 18, right? Because I'd have 10 and 8 more.
Daddy.
Alright, now, so 18, oh very good. And you're going to put them both on the ends. And now I have a 10 and another 10. Put this one here.
Yep, that's what I was about to do.
Alright. So now we have 20 there, right? Okay, so 20 equals 20. Alright.
Okay.
Okay.
Okay, oops.
Oops. You're okay? Alright.
Yeah,
so 20 equals 20.
Yeah.
Alright. So we figured out that 6x plus 2 equals 3x plus 11, and basically when we evaluate these guys, we get 20 and 20. Over here, 6 times 3 is 18, plus 2, 20. 3 times 3 is 9, plus 11, 20. Right? Well, we could look at it another way. Here's my 11. Right? And if I add 9 more, I get 20. Right? Lots of math going on here. Well, in fact, we could do that. Let's make a trade, just for fun. And I'm gonna make that a 10. Right? Well, we got it right here already. Okay. So there's my 11. Now, what is that 1 1?
To be.
To be what? What does 1 want to be?
10.
What does it need?
9.
Oh, look. We give him what he wants. So that 1 is very, very happy. He's a happy 1. Right? Now, I get 2 10s. And I have 20 again.
Yeah.
Right? Okay. And they have never watched. Have you ever watched Beavis and Butthead?
No.
Do you even know who they are?
No. What is it?
Alright. Anyway.
What is Beavis and Butthead?
Oh, it's you're not getting that until you're a teenager. Anyway, okay, so there it is. Last problem. Having fun playing math. Okay, so where do they go to find out more?
Crewton Ramone.com.